equations, solving linear equations, solving quadratic equations, and other types of equations. In this video, we'll look at solving linear equations. An equation is a statement that two mathematical expressions are equal. For example, 3 plus 5 equals 8 is an equation. Most equations that we study in algebra contain variables, which are symbols, usually letters, that stand for numbers. In the equation 4x plus 7 equals 19, the letter x is the variable. We think of x as the unknown in the equation, and our goal is to find the value of x that makes the equation true. The values of the unknown that make the equation true are called the solutions or roots of the equation, and the process of finding the solutions is called solving the equation. Properties of equality. So this is in your notes. The first property, a equals b, is equivalent to a plus c equals b plus c. In other words, adding the same quantity to both sides of an equation gives an equivalent equation. And this is true for any equation. If a equals b, then c times a equals c times b, so long as c does not equal 0. In other words, multiplying both sides of an equation by the same non-zero quantity gives an equivalent equation. Now obviously we can't multiply both sides by 0 because then we would just have 0 equals 0. We would just cancel everything out and there'd be nothing to solve. But you can add and subtract, as in adding a negative number, or multiply or divide, as in multiplying by the reciprocal, by any number other than 0, and you will have an equivalent equation. Solving linear equations. The simplest type of equation is a linear equation or first degree equation. It's called first degree because your variable is to the first power, which is an equation in which each term is either a constant or a non-zero multiple of the variable. In other words, you're not going to have any exponents other than 1 in this particular equation. Linear equations. An equation in one variable is an equation equivalent to one of the form ax plus b equals 0, where a and b are real numbers and x is the variable. Right? So, and you may have more than one x and more than one constant, right? But they're still all raised to the first power. And you can rewrite it in terms of ax plus b equals 0. So here's the first one. Solve the equation 7x minus 4 equals 3x plus 8. All right, so we need to get the variables on one side and the numbers on the other side. So to solve, get the variables on one side, and this should be review. And the numbers on the other side. I like to start with the variables, and I try to keep the variables positive. So in other words, I subtract the smaller one from the larger one. All right, so that means I'm going to subtract 3x from both sides. Actually, you know what? I'm going to rewrite that just so that I'm not crammed up here. It's up to you whether you rewrite it. You don't have to. All right, so I'm going to subtract 3x from both sides. All right, that will give us 4x minus 4 equals 8. Now we've got now written in terms of just one variable term, and now we need to have just one constant, and we can have just one constant by adding 4 to both sides. So that gives us 4x equals 12, and then divide by 4. X is 3. Not too bad at all, right? Let's look at something very similar, except instead of solving for a variable with a number, we're going to solve for a variable by isolating that variable. and that is solving for one variable in terms of another. Solve for the variable m in the equation, and this is the capital M. The lowercase m and the capital M are different things. And this is just an equation from science. Right? A lot of times when we're solving for one variable in terms of another, it's either an equation from science or it's an equation from mathematics for area or volume or something along those lines. All right, so we want to get the m all by itself. So in other words, we want to get rid of the g, the m, and the r squared. I'm going to write that a little friendlier. Right, so f equals that g times the lowercase m times the uppercase m, all divided by r squared. We could move that so that technically that g is in the numerator, right? It's g. Anytime you have a value, it could be rewritten as a fraction. In this case, it would be g over 1. So that means we could rewrite this as capital G times lowercase m times uppercase m, all divided by r squared. Right? So now we want the capital M capital M isolated. Notice that that capital M, I'm going to write it actually like this, is multiplied by the fraction g times lowercase m divided by r squared. If we wanted to get m by itself, we could just multiply by the reciprocal of g times lowercase m divided by r squared. All right, so if we do it to one side, we have to do it to the other side. All right, I'm going to color code this one. All right, so I'm going to multiply this side by r squared divided by capital G times lowercase m times f equals g times m times r squared times m, and I'll multiply that side by r squared divided by g times m. Now you don't have to do it all in one step, right? But I saw that I could, so why not? All right, so this will cancel, and this will cancel. So now, on the left-hand side, let's combine these, right? We can think of that as f divided by 1. So that f goes to the numerator. This would be f, it doesn't matter which order you put things in. I think I'll put the f first, times r squared divided by g times lowercase m equals the uppercase m. I'll try to make it nice and big. All right, and that's all there is to it. You still do the same things. If you've got something added, right, you add the opposite. If you've got something multiplied, you multiply by the reciprocal. Right? And that takes care of it. Let's look at one more example. And this is solving for one variable in terms of another. The surface area A of the closed rectangular box in figure 1 can be calculated from the length L, the width W, and the height H according to the following formula. Area equals 2 times length times width plus 2 times width times height plus 2 times length times height. All right, you've got 6 sides on a rectangular prism, and the opposite sides are congruent to one another, right? So the top and bottom are congruent, the whatever you want to call the front and back are congruent, and the two sides are congruent. All right, so now we want to solve for W. We want to get W by itself. And you will do problems like this in calculus because you're trying to rewrite one variable in terms of another, because maybe you don't want two variables, and you know something you could rewrite. If you rewrite it in terms of one variable, you could replace that in another equation, and then you'd have an equation that was only written in terms of one variable. And I'll show you what I mean. So area equals 2 times length times width plus 2 times width times height plus 2 times length times height. All right, so we're going to solve for W. So if it doesn't have a W, we want to move it to the other side. Right? So we have a 2 times length times height, and that does not have a w with it. So let's move it over. It's no part of w. So area A minus, right, we're going to subtract, actually, you know what, I'll write that. We're going to subtract 2 times length times height from both sides of the equation. And that'll give us on one side, on the left side, A minus 2 times length times height. Obviously, we can't combine them. It's not like terms. Equals 2 times length times width plus 2 times width times height. And if you notice, those things cannot be combined. They are not like terms. They do not have all the same variables. One has an L, one has an H. Not the same. But we want to get the W all by itself. Notice they both have a W. It's a common factor. By the way, the 2 is a common factor as well, but we're solving in terms of W, right, and we actually don't want the 2. If we take the 2 out, then we're just going to give ourselves another step to do later on. Let's just factor the W out, since that's what we're interested in solving for. So A minus 2 times L times H equals, so we'll factor a W out. 2L times W would be 2L. 2 times W times height divided by W would be 2H. Now we've got the W factored out. We've got a product. We've got W times 2 lengths plus 2 heights on the other side. If we want to get, and so technically this is a coefficient right here. If we want to get rid of that coefficient, we'll just divide both sides by 2 times length plus 2 times height. So we're going to divide this side by 2 times length plus 2 times height. And this side by 2 times length plus 2 times height. And now we have this written in terms of one variable. Area minus 2 times length times height divided by 2 lengths plus 2 heights equals W. Now why would you want to do that? Well, perhaps you want to solve for width. You know the area, you know the length, you know the height. You've got width all isolated. If you plug in the area, the length, and the height, then you can solve. All you got to do is simplify and you'll have width. Right? What if you had this equation? So we have volume. So the volume of this box would be calculated by length times width times height. Now let's say you know the volume and the length, and you don't know the width and the height. Right? And that's too many variables. You can only solve for one variable at a time. If you rewrite it in terms of width, now you could replace width with this expression. A minus 2LH divided by 2L plus 2H. And then you would only have one unknown. So volume equals length. I'm going to put length and height together. The expression for width is, let's make bigger parentheses there. A minus 2 times length times height divided by 2 times length plus 2 times height. All right, so now let's say we know the length and the height. All right, let's say we know the length and height, we don't know the volume. Now we could calculate the volume because we have an expression for width that does not involve us knowing the width. So let's say we only knew the length and the height. So let's say the length is 10 and the height is 5. And I don't know what the width is, right? And I know the area, I'm just making up the numbers, is, well, let's see, I've already got, let's see, this would be, so the one side here, back here would be 50, 100, let's say it's 500. I don't want to have it be too small a number, right? And so if we knew the area, we knew the length, and we knew the height, we could just plug in the values and find the volume, right? So in this case, my made up numbers here, 10 times 5 times 500 minus 2 times 10 and by the way, you don't have to put this in your notes. Times 5, I was just showing you an example of why it might be important. And then 2 times 10 plus 2 times 5. So now all I would have to do is just simplify that, and I could find the volume even though I don't know the width. All right? So that would be a purpose for rewriting in terms of one variable. You'll use this in calculus to find, for instance, the box that will maximize your volume while minimizing your costs. So that's the end of this podcast. That should be my last slide, I think. Let me double check. Yep. So thanks for watching, and bye for now.